Now this is my favorite. So of all the things that we're going to do in this class, this is one of the favorite things that I see, and that's because I like the challenge. I like having to look through and problem solve and try and figure out what identity am I going to use to do this. And so here's the idea. We are going to do a bunch of stuff to this side of the equation so that once I'm all down at the bottom, it says this side. I'm not going to move anything over here. If you move something over here, it's wrong. We do not touch this side. Basically what we're doing is we're saying we're starting here, and I'm giving you the map. I'm giving you directions on how to get here. So it's like saying, how do I get from McIntosh to Red Lake Falls? What do I have to do in between? We don't jump from talking to McIntosh and then talking about Red Lake Falls and then talking about McIntosh and talking about Red Lake Falls. We do everything from McIntosh until we get to Red Lake Falls. So ignore this side for now. What I'm going to do here, and a lot of times one of the tricks is when you are trying to do this, is turn everything into sine and cosine. So I'm going to replace the secant with its reciprocal. So now I have sine of x times the secant is 1 over cosine. Okay, and so then that means I have sine over cosine. So then I am going to multiply those out. So now I have sine of x over cosine x. And if you look at your quotient identity, sine of x over cosine of x is tangent of x, which is exactly what I wanted to get. And so we put a little box at the end or a QED to say that we're done with this proof. Okay. Now one thing maybe I should have done is written the original thing. So sine of x times secant of x equals these things so that I can follow and I see that the first thing is the beginning and the last thing is at the end. And so basically I'm filling in this stuff in here. What does that equal sign mean? This is what really, if you look microscopically and we zoom in on the equal sign, this is what we would see because it tells us how it's equal. Okay, let's try another. All right, so here, turning things into sine and cosine isn't going to help. Because it's squared and it's just going to be messy. But if I look at the Pythagorean identities, I'm going to see that the third Pythagorean identity says 1 plus cotangent squared equals cosecant squared. And the reason this is useful is because if we look at what we have here, this is cotangent squared and cosecant squared. That's exactly what I have there. So what I'm going to do is I see I have a cosecant squared here, and this thing actually equals cosecant squared. So I'm going to take this, I'm going to plug it in for cosecant squared, using a bubble, of course. So I have cotangent squared minus, now I'm going to replace cosecant squared, 1 plus cotangent squared. Okay. Oh, I did it again, didn't I? Or I didn't do it again. I need to start by saying what I have originally. Oh, that should be an x, shouldn't it? Minus cosecant squared equals that. And then I'm going to distribute my minus sign. So now I'm just going to do the math that I see here. So then it's minus 1 minus cotangent squared. And cotangent squared minus cotangent squared cancel out. And so I'm left with negative 1, which is exactly what I wanted. And so then I'm done. So that, I know I made it seem easy, didn't I? But really it's just a matter of stepping back and identifying identities that look similar or that you think might help and then seeing what you can do with that. In this one we use substitution to help us solve. Okay, so another example. Here, if you look at this, you're going to see that I have a bubble times another bubble. And so we need a box. Whenever you have a bubble times a bubble, you need a box. Okay, so we take secant plus tangent times secant minus tangent. And let me do this right this time. So I'm going to start with what I have. What I have written above is not actually the beginning of my problem. It's just telling me what the problem is. So I need to write down what I have. Okay, and then if I multiply that out, if I go through this whole bubble work, I'm going to get secant squared minus tangent squared. Okay, and now that's supposed to equal 1. Well, let's see here. If I look off at my identities, I have 1 plus tangent squared equals secant squared. So this looks like another one of those, take that and plug it in for secant squared using a bubble. So 1 plus tangent squared minus tangent squared. And then there's nothing to distribute, so now I'm looking at it and I see that I have a tangent squared minus tangent squared. Those cancel, and so I just get 1, which is exactly what I wanted. Okay, so this one, whenever you see bubbles like this with a plus or a minus or whatever, whenever you see bubbles, you need to go ahead and box it out and see what you get. Okay, now for this one looks kind of scary if you look at it. We have secant to the fourth minus tangent to the fourth somehow becomes secant squared plus tangent squared. So that one seems a little bit scary. Now what we're going to do though is I'm going to take this and write it down. So secant squared minus tangent, sorry, I lied. Secant to the fourth minus tangent to the fourth x, okay? And then to figure out what that equals, that's going to be a box it out kind of thing. Okay, only now it's inside and I'm trying to figure out what's on the outside. So secant to the fourth minus tangent to the fourth. And so this is one of those squared things. So secant squared times secant squared is how I'm going to get the secant to the fourth. Tangent squared times tangent squared is how I'm going to get to the fourth there. Only one of them needs to be negative. So then what happens is I get secant squared, tangent squared, minus secant squared, tangent squared, and those two are going to cancel out. Okay, and so that's how we get that. So then my two bubbles that I get are secant squared x plus tangent squared x times the other bubble, secant squared x minus tangent squared x. Now, secant squared and tangent squared, we have this identity, 1 plus tangent squared equals secant squared. Okay, so here's another thing that I'm going to do. Sometimes you want to not necessarily substitute, because we could here, but I want to try something different this time. Instead of substituting, what I'm going to do is I'm going to manipulate this identity first and then substitute. Because what I want to do is I want to get this identity to look like this, exactly like this. If you notice, I have secant squared minus tangent squared. So if I subtract tangent squared there, so I'm going to subtract tangent squared from both sides. So I'm just manipulating the identity. It's still going to be the same thing. So now I get 1 equals secant squared minus tangent squared, which you'll notice is the exact same thing as I have up here. So that means I can replace that with 1. So now I have secant squared plus tangent squared x. All of that is times 1, because that's what that equals. Now, what I've done is I've taken an identity and I manipulated it. This work needs to be seen on your paper, because I need to know how this is 1, because this is not directly the identity. It had to be manipulated. So I need to see that manipulation to prove to me that it is 1. Okay, so make sure you have this somewhere on your paper. And then, if we notice, this is just my answer. All of that times 1 is secant squared plus tangent squared, which is exactly what I wanted to get. And so we're done here. And the last show you is one of these. And these usually tend to be the most frustrating ones for people, so we'll go over it now. So we have cosine theta over 1 minus sine theta. Now, if you remember complex conjugates, we would multiply by the conjugate. Well, we're going to do that same kind of thing now. I'm going to take the bottom, I'm going to multiply 1 plus sine squared. It was just sine, 1 plus sine. Okay, so that's my hint to you. When you have a fraction like this, and it's just the one fraction, and this bottom has something, a minus or a plus here, multiply by the conjugate. Okay, now on top, we have cosine theta, and I'm just going to leave it as 1 plus sine theta for right now. We might change it, we might not. But on the bottom is what I'm more interested in. If you FOIL that out, or you box that out, you're going to get 1 minus sine squared. So this is another one of those moments where we're going to look at our identity, and we have sine squared plus cosine squared equals 1. And if I take and if I subtract sine squared from both sides, we get cosine squared equals 1 minus sine squared. Okay, so that means on the bottom, I can replace that 1 minus sine squared with cosine squared. And then on top, I still have cosine times 1 plus sine. Now I'm glad I didn't multiply those through yet, because if you look at this, I have a cosine on top and a cosine squared on bottom. One of those will cancel out one of these here. Okay, so now we have 1 plus sine over cosine, which you might be looking at that saying it looks a lot similar to the same one, But here's what's cool about this. When you have a plus on the top, you're saying this is being divided by cosine and this is being divided by cosine. I can divide them separately. So I'm going to split those up. I'm going to have 1 over cosine plus sine over cosine. And if we keep in mind what we're trying to get secant, which is 1 over cosine, so I can replace that, plus tangent, which is sine over cosine, which is exactly what we have. So we are done now. We got our final answer. I know these are difficult. I know they are frustrating. You have to practice, practice, practice these. Hopefully, if you're stuck, there's a problem within this video that helped you. If not, let me know and we'll go over it. Good luck.